In this lesson, I will present an evaluation of thread creation approaches. At level 1, threads are created. Using the traditional approach, this approach should be avoided in production environments. Traditional thread creation is manually managed, has no pool, no resource limits, and is difficult to manage. These drawbacks make it unsuitable for production usage. At level 2, we use the executor utility, the executor abstraction. This is better than level 1 because we can limit the thread count to 10. This pool has a maximum of 10 threads. It is easy to manage the lifecycle as it provides methods such as shutdown and other lifecycle APIs. Now note this. For example, we configure a pool with 10 threads. Pay attention here. This does not guarantee that which is out of memory will not occur. If the tasks executed by those 10 threads are too heavy, the system can still run out of memory. At a more advanced level, we have thread pool executor. When creating it, we provide parameters, such as core pool size and max pool size. The core pool size means, even with no tasks or just on startup, it still creates 5 threads. Even without tasks, those 5 threads exist. And the maximum pool size allows, at most 10 threads. Threads from 6 to 10 will remain alive for 60 seconds, then they are terminated. Custom queues, custom thread factories, and rejection policies. This approach is more complete and flexible. Full control. That is the summary. Now at level 4. Level 4 introduces virtual threads. Virtual threads were introduced in Java 21. In previous slides, we already covered the architecture of virtual threads. Now let's review it again. With virtual threads, we can create millions of threads concurrently. Platform threads, on the other hand, depend on the CPU capacity. They depend on the number of cores. Virtual threads are lightweight and very cheap to create. They are typically used for I/O-bound workloads. I/O-bound refers to workloads where execution time depends on network latency, input and output operations, and database query latency. These types of tasks are well suited for virtual threads. In JDK 25, virtual thread support is much more mature. Using JFR, we can observe detailed behavior, much more detailed metrics. Let's summarize. Virtual threads allow creating millions of tasks, whereas the traditional approach, with platform threads, maps threads one-to-one to CPU cores. That's the difference. Why do we say it is simple? Because the APIs are built in. We only need to add the keyword virtual. That's it. Just add the word virtual. No complex configuration is required. It was introduced in Java 21. By Java 25, it is now stable. It is production ready. This is a major breakthrough in concurrent programming. It is highly effective for real-world applications. Thank you. See you in the next lesson.